Hey, I think we are live. Let me check. Um, I think we should be live. Let's check. Yep, we are live. Nice. I think yeah, I should be audible. Oh, is this stream like paused or something? Not sure. Let's see. Hmm. Is the stream even live? Are we live? Are we not live? I can't really. Okay, we are. Nice. Okay. Welcome back to another weekend dev stream. It's me alone this time, but that's fine. Ha, this time it's fine. So we left off at this thing, doing the video encoder, right? So last time I think when we did that, we had some issues. Basically, the video encoder was not working correctly. So let's see. Yeah, okay. I think it should be visible clearly. Great. Just the camera, but yeah. Okay, great. Sleep mode. Hmm, nice. Okay, yeah. So picking up where we left off, this was where we left off. We did the conversion from RGB to YUV. We basically created our entire encoder correctly, right? So it only thing was that was left was doing the like run length encoding, basically doing the deflation, that is compression from the keyframe and all of this. So this part is left. Let's mark it accordingly. You can mark it as this color. Same for here. We can change the color. Oh, it's a shift 4, shift 5. Okay, nice. Good to know. Flatten in single slice for each frame. Downsampling is done, flattening is done. Yeah, so these 4 tasks are done. And actually, we can even see the result here. Oh, okay, what is happening? Oh no, uh, I had just what? Okay, okay, there we go. Right. So I have made a few changes. Basically, I was able to figure out why we were getting the error we were getting last time. So I'll just show you what error we're getting in the first place. So the program worked, right? If we see there's no errors now, let's run this. So we get this ugly blue and white, with this blue sort of leaking over here, and the green is entirely covering. It's not. It's ugly. It doesn't look good. So after after my expert investigation, what I found out was that I can't type clearly. So this +1 +2 thing that was distorted, that was causing it to be distorted, right? So this basically caused an indexing issue. One more thing was the index. See, this is supposed to be multiplication. not addition, because we want r by 2 times the stride of the entire sort of loop. I don't know how to correctly explain it. Maybe I can just show it now. See, so now there are no patches, but the video is clearly really, the color is really messed up. So only the blue is correctly in place, but the greens and the yellows are all messed up. Now, why is that? The reason is that since we are converting it into an unsigned int over here, there's an underflow in the colors. So what does that mean? So we have colors which are negative as well as positive. So all negative colors are basically like tilting towards the green side for the U and V. So underflow basically causes the minus 100. I guess it's like green color to become 250. Yeah, 256 is the max, and then it becomes 246 because it underflows. So there is no way of storing negative values in an unsigned integer 8 variable. It has unsigned int 8 is basically 2 to the power 8 and unsigned. So what we'll do is we'll add 128 here as a constant. So this is like a clamp, by the way. Well, we will use a more sophisticated version of this, but for now, this is our clamp. And what we'll be doing with this is we'll be able to successfully sort of circumvent that whole problem of having that color bleeding and underflow of the unsigned int. Let's run this. Right, see now the video is perfect. Too good. Yeah. I actually had one more video that I had added. Well, let's first commit all of these changes. Uh, fix, fixed, correct, underscore issue, and color sampling index. Let's push this change. I don't want to push this encoded by UV or whatever because I mean, what's the point? So I actually had uh, something lined up here. I'm not sure if, let's see if I have it in downloads or I'll have to download it again. Yeah, I think I'll have to download it again. Uh, let's see. Or we can just what I wanted to do was basically find like a stock image which I could download. 1 second, I'll download it. I can't really show the source of where I'm downloading it because that would leak my personal credentials. We don't want that happening, right? So, okay, I have downloaded it. Great. Uh, let's let me just copy it over. Should be here. Yeah, it is. Okay. Okay. Yeah, this time I'm going to copy it over, not. Yeah. Okay. Yeah, I think we are done. So I have this video, this video.mp3. So This is actually a video of me on a fort that I've recorded. So fort video.mp4, right? I do have a command that we can use to sort of encode it back, but I don't know the shape and size of this video. Like I don't know the height or width of this video. So let's go online and, or I guess we could open it up in VLC as well, right? Yeah. So let's open this. Open with VLC media player. Let's look at the properties as well. Okay, we don't have support for H.264 format. Okay, fine. That's why VLC can't play it. But do we have? We don't have the dimensions. Do we? Oh, we do. 624 by 832. I will note it down somewhere. It's noted down here. What was it? 624 by 832. 6, no, 624, 832. Let's see. 624, 832. Okay, great, great, great. So pixel format is already YUV 420p. I am not sure. Um, can we convert the codec online from, let's see, H.264, H.265 converter? Yeah, we do. Okay, we can. Looks like we can do that. Let's let's do that. No, it's not project. Here we go. We have the fourth video. Oh, it's actually pretty small. Yeah, it's completed and it's showing 0. Okay, what? Well, it's 0 KB. I don't know why is that. Never mind. Yeah, I don't get it. Fine. I mean, I'll try that command over here. We'll see if it works or not. ffmpeg, I think it's input dash I Ford video dash F Ford raw dot RGB 24. We'll do EIX empty RGB 24 and at least one file must be specified. Did it convert or not? No. Oh, what did I not specify? Not file F. Oh, okay, maybe. A little confused. No, yes. How to convert MP4 to P24 using FFmpeg. Uh, FFmpeg input dash VF format. Oh, okay. Ooh, I guess. Hmm. Okay. So we'll say Fort V24. Pixel format is there. VF format equals, and we'll have to put the Fort video here. Fort. Hmm. Okay. Unable to choose output format for user standard extensions. I need to put RGB. Okay, that worked. Oh, that worked. So we'll do cat Fort video dot RGB go main.go. Okay. Did we? Oh, right. It auto defaults to this thing, encoded.yuv. So let's play that. Oh God. Oh no. Why is this happening? I think it's just the conversion messed up. Let's convert it online. Convert MP4 to RGB24. Ah, okay. I mean, I don't really care about this being like, you know, like a user. There's no accept data or anything on this, so it's fine. RGB, but then is there no RGB24? No, there is not. Okay, fine. I mean, it's already so compressed, so I'm not sure. Let's check for other alternatives. Now, MP4 to RGB24. Let's download it. I am not sure. Oh, it's a zip file. Why does it have to be a zip file, man? It's mildly concerning. Clipboard is empty. Yes, dude. I don't like this. Where's the zip file? Oh, no. Okay. So we have a 1.4. Why are there four? No, it's just it's right here. Yeah, I don't know. I'm just taking all of them. Let's say we'll delete the. Whoa. Okay. Let's see, Fort video. Yeah, I don't know what's the difference between RGB and RGB24. No clue. Yeah, Fort video 1. No sulfur. What? Main.go. Okay. The six, we got six. It's going to be hella short. Yeah, what the heck? Okay, now there's something going wrong with the conversion here. I don't know. This is chalk, bro. What the difference between RGB and RGB 24? Because it could be 24 allocating each. Yeah, RGB is a color model. Okay. Um. Okay. Let's see how to convert. Let's actually what we'll do is for yeah then dash f 20 RGB 24 um for video RGB 24. Okay, okay, looks like we did cat for video for um oh wait, yeah, we never mentioned the height also. That could be it. Oh no, what's the yikes. Also, yeah, we never do the flags dot parse. Um, no, flag dot parse. Yeah, so since we are not doing that, the flags never get parsed actually. Yeah, it's HT and WT. So the height was 6, 8. No, it's width first and then height always. No, so the width was 624, 624, and 832. Let's hope for the best. HT and WT. Flag provided but not defined. Oh, it was WD. Okay. Yikes, dude. What is happening? Why is it FF play raw video pixel format? Why UP 420p? Oh, because the video size is wrong. This also needs to be 624832. 624832. Let help. Oh yeah, it does. Yo, let's go. What? Yeah, that is so sick. Yo, no, that is my video. I just took that shit. Oh yeah, dude. Yo, it was just the hype. Damn. Nice. This is so sick. I could actually watch this all day. This is sick. Nice. I love this. This is so cool. It worked. Me happy. Oh my god. Nice. Oh. Yeah, so it was a height thing. It was a height thing. Let's check the byte size. So, okay, this is. Oh, also, this is much, this thing, more, yeah, higher in size or much more weighty or whatever you want to call it than whatever test we were using earlier. So, how much is this like? 440, 25, 325. So, yeah, so it's like 171 million bytes that we are compressing into 8 million bytes. Yeah, it's 8 million six five. No, what? No, 720. Yeah, it's 85 million. Okay, it's 85 million. Yeah, that's why we're compressing it into. And this is 53 million. Yeah. Okay, good, good. Hell yeah, I like it. You know what I can do? I can probably film one like right now as well, or like later. Yeah, and then we can add that as another one. Yo, that was so sick. I am so happy. That's actually right. Also, yeah, let's just shorten it to H and W. Oh, actually, I'll have to keep this as HT and width. Okay, fine, whatever. We do have the dimensions written over here, so that's fine. Okay. Moving on, now I think the next step is that we basically do an encoding of the first frame. So what we do is we take the first frame as a keyframe, and then whatever the next frames are, we'll basically subtract all of them from the first frame and only keep the paths that were moving. I think that will significantly sort of, yeah, reduce this whole. Oh, also we should play. 4 video MP4. So this is the original video. Is the audio? Yeah. So this is the original video that I just played right now. And I don't know. I mean, you don't see a lot of noticeable drop in quality, no? I mean, there's obviously the audio that's completely gone, but other than that, I guess it's not like a noticeable drop in size as well, to be fair. Uh, yeah, I mean, the quality, the only place where we have sort of compromised or basically done this thing, what to say, reduction is doing the encoding. Uh, Also, I think I should probably play not this one, but the RGB 24 one. 24, I can't, okay. What do I need? I think I need a fifth player of video pixel 25 port video dot RGB 24 frame rate is fine. This is fine. Should be RGB 24. Okay. How does this look? I mean, to be fair, I can't really make out the subtleties here too much. I like legit cannot differentiate between the two. So I think we've done pretty good job so far. Anyways, now moving on. So our write file to disk thing is done. Our encoding is done. Now we'll move on to the new task. Find keyframe and delta from the keyframe. So let me open the chat. Do we have any chats today? No, we don't. Okay, it's fine. It's okay. What's up, chat? What's up, YouTube? Dude, I'm just so happy that this thing works. I could not be happier. Sir. Okay. So, okay. What we want to do next is show size. This is fine. We'll write a function which will basically do these two things: find keyframe and delta from keyframe, and then compress the keyframe and delta. So let's see. We want to find keyframe and deflate. Uh, let's be. Whoa! Why is this jittering so much? I don't know. Whoa, that's crazy, bro. Okay. Anyways, what? So find keyframe and deflate. Should find keyframe. No, find keyframe deflate. Okay. What do we need? We obviously need frames. But I don't know what the type of frames is. I forgot. It is byte, a 2D array of bytes. Okay. And I mean, we will return the same thing. It will just be smaller, but that's fine. You don't need to specify that right now. Okay. We have a return type. We have this. We have that. Now what we'll do is for frames. Um, so initial one we'll take as the keyframe. So that's okay. If So what you want is then frames of I, the keyframe. Okay, frames of I. Great. We have a keyframe. We'll make byte. Ah, why is it doing so much? I hate that. It should be len of frames. Right, we want it to be the same, and then encoded frames of my keyframe. Okay, great. So if it is made now, we need to find a delta or difference or whatever. Difference, we do that by just subtracting, I think. I'm pretty sure. Let's see. Encoding RL. Let's actually look at the tools. How does he do it? Mr. Kevmo. Lossless data compression runs data consecutive, blah blah blah. So I think he does it as an exercise, and they use, but they still use the delta. Uh, I think so. I mean, we are going to use the delta anyways, regardless. Not just, yeah. So this is the one. So they took the keyframe. Oh yeah, I didn't do the continue one, right? We should do that. Yeah. Delta make whatever, and then get delta of j. Oh, frames of I of j. Yeah, I mean, you're just subtracting. That's fine. Just going row by row. What do you do after that's done? Delta frame, whatever. This is run length encoding is no longer used in modern codecs. Blah blah blah. Count number of times value repeats. Right. So correct. So this was the part. Yeah, we. Oh, my bad. Bit sleepy. But yeah, okay. What I meant, I actually misspoke. What I was actually referring to run length encoding was this part, which I was trying to do here, the difference part. Uh, yeah, I basically wanted to say keyframes, but yeah, I misspoke. I'll really byte j this. So this part we won't be doing because this is the run length one. We will be using like a compression library that they use in gzip or zip, yeah. So this is the one. I think what he's done is just go create an object or whatever, then we write the raw keyframe, we write the raw delta, and we deflate it. Okay. Once it's deflated, we will decode it, split the inflated stream into frames. Okay, well, he's saying that this is like typical JPEG compression. So why can't we JPEG encode each frame? Because the above algorithm is quite simpler than JPEG. We demonstrate taking advantage of temporal locality can yield compression ratios just as high as JPEG with much simpler algorithm. Deflate does not take advantage of the two-dimensionality of data, and therefore is not efficient as it could be. Okay, yeah, I mean we are not really uh, competing with any modern video encoders. They're really complex. So yeah, and this is just sort of a peep into something much deeper. I just getting to know shit on a fundamental level, right? So that's what this is. So okay, these two things are left. This is just, I think, the decoding part. So we can do that once we are done with this final step of deflating and where did it go? Yeah, deflating and compressing it, which is the same thing. Yeah, I meant the keyframe and deflation. I'll be back after a small break. This will be quick. Hello, we're back. Welcome back. Okay, thanks. Let me log back. Okay, so we have the difference now, or the delta, which we want to. Okay, wait, where is that? Yeah, so we have the delta, which we. What the hell? What the hell? Why? Why is this going like that? Okay, we want it to be a byte, just the same as frames, and we want it to be the length of frames. Yeah, there we go. For I, no, for j, with j equals 0, j is less than length of frames, j is equals 1. We will do a for loop. Actually, it needs to be one smaller, since j is not actually going to be like what to say. This should be difference, which again is the same as length of frames. Oh wait, my bad. This is supposed to be length of frames of I. Yeah. So then this also is supposed to be a single array. My bad. I thought difference was supposed to be like this thing. Multi-dimensional array to hold all of, yeah. But okay, difference of yes. No, we want frames of I, J. See, this is where I don't understand, because we want frames of I plus 1. So what we want is the next row, uh, uh, what the hell? Because if I do -1, will it not start at 0? Wait, should it be difference of I or no, it should be difference of j. What's the issue here? Oh, yeah. Loop can be modernized for using range over int. Okay, also. Uh, Yes, yeah, that also works. Yeah, that does work. I mean, it's the same thing. It's literally the line of delta, and this is the same. Yeah, so it's fine. So now, so the Oh wait, yeah, no, no, no. Okay, no, I minus one is correct because this is the first frame, and so yeah, it's the current frame minus the key frame. Yep. Okay. Frames are fine. I mean, we don't really care what the sign is, regardless. We just want some relative, let's say, yeah. So this is fine. We can put an else here. Put it in here. It needs to be on the same line. Okay. So we have the delta now. So we have difference basically is what I'm trying to say. Now we want to deflate this difference, right? Hmm. Let's see what basically we can do about this deflation issue. 1 second, let's just do the else. Hmm. Okay, stream description. Okay, let's check how he handles this thing. Okay, so we've done this. We're not doing whatever this encoded RLE stuff is. Yeah, keyframe, write the raw frame. What is bytes dot buffer? How do you use this function? So basically, for each and every frame, for the keyframe, we write it separately, and yeah. So we frames of 5j minus this frames and w dot. So you're just doing the same thing over and over again. Even in RLE, is the same pattern. Since you're not following it, you won't do this. We'll just directly add it. Okay, looks pretty straightforward then. After that, we can do. I think we can do the decoding on our own. Let's look at bytes.buffer. What package is that? I want to know what. functions. What does the function mean? Okay, it looks like it's bytes of. How do you compress it? That is my question. New writer fleet.best. Okay, this thing. Yeah. So this W is the. And what is deflated then? Deflated is just a reference you give at the start. Okay. Yeah, I think what is it? It's so fleet.best compression is just this part. The buffer.writer is what we used to just simply write and close. Okay, fine. Let's still have it here. Where is write? How to compress using fleet as Golang. Golang. Fleet. Okay, example dictionary, example reset, synchronization. We have constants, writer, yes. Mine, but compress more. Let's go. Okay. Oh, writer, use audio. Mm, new writer, and we will also need this thing, right? For writing. There was like a reference we added. Mm, Late, not writer. Uh, W. For this, we can add keyframe deflate. We'll have to put it as byte start buffer, and here we can give it reference now. That works. Okay. And here we do create a best compression. Okay. Nice. Now also we need a w comma error if error equals nil, log dot control uh, Why can't we just do it this time? W is that's fine. Yeah. So mm, how do I just write the keyframe? The right is not checked. Okay, if keyframe now, what do they even mean by error check? Oh, they mean the error, the actual error. Also, frames of it's frames of I. So mm, mm, w dot write keyframe. You'll have the keyframe written if now equals new. Um, is logged out fatal ln is b. Right, there we go. Nice. Yeah, I think this is fine. Difference, we are getting the difference. We can, I think, just write the difference here itself. Uh, yeah. So error is dot right. Just say difference and if same thing. Uh, so error. Oh no. Did we mess up? No, we did not. It's under an if else, so this is fine. If error is not equals nil, it'll error. This is fine. We are handling the errors as well. W dot write difference. I think everything else is fine. So we are writing the difference as well as okay, we are writing it into the buffer. Let's make sure that the buffer is outside the loop. Yeah, it is. Okay, nice. Okay, it is. Just making sure. After that, yeah, we are having this. Okay, this is fine then. Encoded frames, I don't think we need. Yeah, let's give this away. And then I think we can close it up. Close. Uh, oh wait, there is this thing. Defer. How do you do it? No, no, no. Let's go in Golang. So you're supposed to do defer for all file writing so that even if something goes wrong, let's see. Example. There we go. Go by example, my hero. Defer close file F. Okay, so you just give that and the argument. So we do w dot close. Yeah, okay. I think we should do this immediately after this now. Before w dot close, create file. Yo, what? F create file, defer close file. Oh, so we want to. Hmm. I have to check this one once. So yes, we want that file to be closed before this function returns. That is true. I think we should be good then now. Uh, 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 how do I? Okay. Uh, must not be size. Okay, the code. Do arrow function here. Expressions in the file must not be parenthesized. How do I? Is it always? Yeah. Oh, so you say I should have a separate function for close file. That's kind of lame. Whatever. No, you know what? I'm just gonna close it here. Yeah. Wait, what does it return? It returns error. Right. Okay. There's no. Um, okay, great. Hmm. Nice, nice. So find keyframe and deflate. I think. No, I'm not sure. Let's see. Uh, Change that. Okay. Yeah. Encoded.yv. Wait. No, I don't understand this. Like, what do we name? Like, okay, we are doing all of this. Why it's still buffer and no. Uh, but what do we name the file? Uh, hmm. First of all, let's just call it write file to disk encoded.yuv. Okay, let's sync now. Keyframe. Okay, converted frames. So this is what we used to write it. Was write file, new writer. So io.writer. Okay, let's check. Example of something. Golang writing files. File path.join os.write file. I want an object that basically writes this. Okay, we have it in buff IO, which is fine. I think this accepts it, no? New writer. IO.writer, okay. Let's see, instead of this, if we say keyframe default, keyframe writer equals buff IO. Oh no, wait, F, what is it? F, what is that create? Oh, what the hell? Hmm. Oh, no, I think closes and flashes, that is fine. New writer, new DST. IO.writer. It's like an interface, multi-writer, writer, and writer 2. What does multi? Uh, what the hell is this? This is just writer. Writer in itself is interface. Hmm. Don't want this one. We want puff IO, and they have. So fine, we can try this. Okay, whatever. Write file to disk name equal to full. Hey, I'm back now. Rat Mike says manual programming in 26 and gives me a salute. Thanks, man. I do it for learning primarily. This is the thing with chat is not I can't see the timestamps also, so I can't check if they've respond like when did they even type the response. I'm not sure, but okay. Oh well. Ah, okay. Yeah, I'm not sure how am I even going to write this because my God. I mean, we do have a writer and all of this and whatever. Uh, mm, okay, what we can do is probably we can write a keyframe deflate bytes buffer. Okay, fine. But my question is, where is the new writer even writing this? New writer returns a new writer compressing data at a given level. Okay, what does this do? It will eventually, it's underlying writer. Okay, what? What does that even mean? writes data to W, which will eventually write the compressed form of data to its underlying writer. But there is no underlying writer here. There is this one, which is bytes.buffer. Okay, so it's just a bytes.buffer. So I guess I could do write file to disk, or we could just return this. Yeah, let's do that. Return the raw data. It's such a good idea. Inflated. Mm, yeah, it should actually be star. And I should be returning the reference to it. I think this is the right approach. I'm not sure though how good I mean returning a reference is, because I can't explicitly manage memory in Golang. So yeah, my limits. I have my limitations. Yeah, deflated bytes. I will say write bytes to disk. Say info head we uh, so, yeah, we don't have one, so we'll make one. Uh, if we have this, we will just bytes this. Okay, we have the output name here. All of this is fine. Uh, this is just going to be bytes dot buffer. Just bytes. Because I think no, what? What's the error? No use of package bytes not in selector. What does it want? Data byte. Oh, wait, no, it should be file, I think. Cannot use file. Okay. How to buffer to write and Golang. Bytes. Okay. So hold on. Oh, there you go. Nice. Well, let's hope this works. I'm not sure. Ah, failed. Write bytes to disk. Undefined. Right. Uh, what happened here? Uh, was the name different? Right. Bytes to disk. Oh, here. What do I do here? Uh, oh, well, that's right. Let's hope. Oh, but isn't that going to? And no, cannot take address of file dot bytes. Well, I hope it just doesn't write like you know, the pointer to the file. I mean, it is taking time to compress, so that is good. It should do that. It should eventually stop as well, which I'm hoping it does about now. If it doesn't, yeah, ciao. Ah, please work. Oh, it did. Oh, nice. Sick. What did we get? Encoded.yuv. Okay. Let's play it. We this is yeah, encoded. We'll play the encoded.yuv this time. Okay, what? Why is it invalid size? Screen says this, but says this. Oh, is it because it's compressed? We can't see it. And we can see encoded video.yuv now. Yeah, this is clearly visible. I'm not sure. It could be because it's compressed. Because okay, so compressed videos definitely not made for consumption. So I mean that's fine. I'm not really concerned about that. I actually only we know that it's working fine because it's not like basically messing up anything here. It's supposed to do this. Yeah, that's what I think. I think it's supposed to do this. So we have done the video encoding part. Now we want to do the video decoding part. So I don't know how do I present this in like a really nice presentable fashion. I don't know. Do something like this. Right here. Let's remove this. Here. Remove this arrow. Here. Okay, whatever. Okay. We can do it like this. Right? Yeah. This is good. Yeah. Okay. Nice. Hey, 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 boy. Okay, convert it. Then we downsample it. And we flatten each slice. Whoa, what happened? Uh-oh. Okay, and then we compress it and keyframe delta, blah blah blah. Okay, this was the entire process. Let me just line everything up so it's pretty. Because, okay, okay, there you go. Okay, I think yeah, this is fine. Now we can like assign proper colors. So, no shades for this color. This is fine. Mm, okay, this is probably going to take like a lot of, yeah. Mm, mm. Nice, 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 nice. Okay, nice. Yeah, so this is like proper. Let me just. Yeah. Nice. Actually, these two are the same processes. So these two are quite related. This one is sort of standalone. This is fine. Okay. This also could be gray. Yeah, this is fine. So this is our video encoding part. Now, video decoding is going to be the exact opposite of this. So decoding. So what I'm going to do is read the, what do you say, decompressed this thing, or basically first find keyframe and delta, uh, whatever this compressed keyframe and delta is, we want to inflate it or decompress it. So here we go. Write bytes to disk. Should we read them, or should we just you know get the reference because we have the reference? Yeah, I think we should read it. Read from disk. We have the, oh no, I think we just need the file name, no? So yeah, okay. Can I, what do I do? Dot, no, dot, bytes, no, no. For dot, what do I have? Nothing. Okay, fine. So we get read bytes from disk, whatever the compressed stuff was, and now we have bytes of this. We want to decompress this. So let's go here. Oh yeah, actually we should also try to do like a config file for this, or not. I mean, we are giving flags though, so yeah, that's fair. Write bytes to disk, write file to disk. read bytes from disk. um, Encoded. So we do get real say bytes to inflate. Same as almost actually. Almost same as um yeah, actually I'm not sure about this. Let's go here and it should return a byte. No, yeah, it should return bytes only. Yes, things so in the end. Uh, let's see. We have the method. Yeah, so right. Hmm. Bytes to inflate. Yeah. So bytes to inflate declare the numbers because and that's fine. What we will do now is first inflate this. So inflated bytes equals we'll say inflate keyframe delta. We'll take the bytes to inflate. What else will be required? We need to read this. Once it's read, we want to do the reverse. Huh? Yeah, I'm actually not 100% sure how we are going to even approach this. So let's see. Yeah, we have bytes. That's what matters. We have bytes. Okay. Uh, I got raw bytes. I know they are deflated. Yeah, I can inflate it. So how do I do that? New writer, there has to be a reader also, no? The actual read needed by new reader. Okay. Okay. No, no, no. So this thing, keyframe deflate bytes dot buffer. We'll do keyframe inflate bytes dot buffer and uh so how Just io.reader, io.read closer. No error. Okay. Does not return. Um, I don't think. No. Uh, no, but we have bytes to inflate. Keyframe inflate equals that. Yeah. Bytes dot buffer. Okay. How to convert that to bytes dot buffer. Convert byte is that method. A byte slice as an argument. What does that mean? Write the slice directly into the buffer. Oh, what? So dot write? No. Uh, oh, buffer dot. Oh, damn. Okay. Keyframe inflate dot write. Uh, bytes to inflate. I think. Okay, cool. Nice. So I think ideally this is what we require, no? Ba, 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 ba. Ba, 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 da, 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 da. R. Yep. So R is the object that we will be able to use to read. Fleet dot new reader. This and there is no error. So R dot read. Oh, nice. How do we even? No. So my question is, how do we even make out that this is sort of the um, uncompressed version of the file, right? How do we even do that? New read, okay. New reader returns a new read closer that can be used to read the uncompressed version of R. It If R does not also implement byte reader, the decompressor may read more data necessary from. Okay, let's check. Okay, byte. No. What methods do you have? Available. Read byte. It does have. Yes. So we write these bytes into this buffer. We inflate new reader keyframe inflate, right? My worry is it's going to be obfuscated. If not, then we'll just have to cut like the first section out, the way we process the raw data. Yeah, something like this. I don't want to do this again. I'm not even sure if this is what we want to do. Yeah, not sure. Mm, okay, you know what? Uh, let's do some math. I think for this we will need the width and height. Damn, decoder is proving to be a little bit tricky. Okay, let's see. Uh, our original height and this thing is compressed as well. We did the flate.new reader. Mm, look, okay, so wait, this is the raw data, right? That we basically read from the disk. Yeah. We also wrote, actually, we are also writing it into this buffer from the. Mm, okay, okay, fine. I don't particularly like it because, fine, whatever, fine. Yeah, we could directly take the deflated this thing, but then the whole writing to file and reading from it doesn't make any point. So yeah, keyframe inflate. This is fine. Right, bytes to inflate. What I'll do is I'll have another var inflated. This is also bytes dot buffer var2. Right. What I want to do is I want to copy all of the if p. Yeah, so this has to be inflated, and this is going to be R. So this we are using to decompress, extract, copy, right? Error is not equals nil. No, log dot fatal error, and then we need to IARR, easiest way possible. Not handling any errors for now. No. I mean, later what we can do is we can, uh, you know, like in the main function or whatever, we can do test cases for this, but I am not particularly interested in that. Ideally, that should be the case. Yeah, like basically writing a test case first, then doing like writing the function. It's the test-driven development sort of approach. Maybe we'll do that from next time. I don't know. No, we have three errors. Not enough arguments and inflate. Oh yeah, we need width and height. Uh-huh. Well, no value. Use this value. Declared not used. What does that even mean? No value. Oh, it does not return any value. Right. That's fine. We will do that. You know, it does return. Uh, yeah, okay, it does now. All right. Okay. Uh, right. So we are extracting it and copying it. Inflate keyframe data. Find keyframe deflate or okay. If error io.copy inflated error not equals nil log fatal ln. We are copying it. Okay, once the copy is done, what we want to do is first of all close the yeah close it. Okay, it does give an error, so we'll have to handle it. What? If error is not equals nil. What? Okay. Oh, it's because. Mhm. Okay. Okay. We'll do the same here as well. Ah, okay. R dot close. So we do have all of the this thing now decoded frames. So make that width times height 3. No, because it'll be. Oh no, wait, times 3. But then we did the encoding as well by 2. So so range of frames was this thing times 3, right? Width and height times 3. So this ran for height times width times 3, and over here it ran for height times width by 2. So it was, yeah, 3 times height width, and जो inner वाला है that is going to be half of height times width. So decoded will be 1.5 times of that. I hope that makes sense, right? Because outer loop ran for width times height times 3, inner loop ran for width times height by 2, right? Resulting. Okay, so we have decoded frames. Now what we want to do is just the ulta now. Will we be able to extract a salad for frame uh, is make, we'll do a why is this, so we'll put height 0. Uh, read full R name. This has to be inflated no? Frame. Is nil and say uh, later we'll add error handling. also. Yeah. But I'm missing type check, comma before an int. What is an int? Okay. Oh, why is this unexpected? What? Type check expected found. Uh, I actually like this way of handling it. It's elegante. Mm, okay, so so now inflated will have the entire frame will have the entire this thing. Decoded frames dot append. Frame. See, I don't like that because this is sort of relying on the fact that okay, this is going to run for whatever iterations you want it to, which again like doesn't fully make sense to me. Like, fine, okay. So this is just inflate frame data, so we'll return the decoded frames. Well, uh, so what did this thing do? Find keyframe data. Did it deflate? Like yeah, it did. Okay, hmm. Fine. So we'll do that as well. Um, so for decoding, okay. Hmm. Decoded frames make byte and width. Okay, this is fine. Now we want to do is we want to take the first frame and take the last frame. Basically, take the keyframe and take the delta, and then create the entire this thing chain of events. Oh, also, oh yeah, see, it's 45 million now. So from 85 to 45, it's like 50%. A little less, but yeah, that's fine. I think that's still an RGB 24. How much is that? Let's calculate. And to be fair, we have not tried it on. We should not. Fine, we will check. We'll check before benchmarking it. properly. Let's complete the program because it won't even run now. Yeah, so that's fine. Um, for so for the range of this in decoded frames, range decoded frames, we'll go. Now the first frame is going to be this thing, the keyframe. But now we need to find the dimensions of the first frame, which is going to be width and height. Yeah, we can skip also, by the way. Yeah, let's just this like tells us correctly, no, and it allows us to add it also. So for j is range when what decoded frames, decoded frames of I. Is that not true? Decoded frames of I j equals s. So yeah, we're just re-adding the keyframe to the delta, and by doing that, yeah, yeah. So I mean, to be fair, this could be like its own function, like just this decoding part conceptually, because it's sort of different from the others. Yeah. So yeah, this whatever we get here is the decoded frames, like proper decoded frames. So you can return this. So I think coded, and I think we can watch this as well. Let's see. Let's hope it doesn't, yeah, error somewhere, because that's also highly unlikely, given that we are writing it and writing it to the disk and reading it again. It would be actually highly unlikely for this to like, just magically pass in the first run. But let's see. Yeah, yeah. So the issue is 190 decoded frames. Okay, what is the issue? Index out of range 0 with length 0. what? Length of decoded frames is 0. Ooh. Okay, for now, let's do one thing. Uh, and deflated, no, deflated star, and we'll, okay, I think we don't even return deflated. That's fine. Keyframe deflate that. Yeah, deflate. Yes, right. Mm, mm. And this is, yeah, yeah, that's fine. So, oh, okay. Mm. Let's try this again. I mean, regardless, we should get to know two things now. What is the actual deflated buffer size? Like, are we even reading something correctly, or is it just all going to waste? Or is there something wrong? Yeah. Okay. Oh, okay. So it's not. Oh, yeah, because we are getting the proper length. Index out of range 0 with length 0. What is the length here then? Let's check. New reader. It's decompressing it. No, then yes. then inflator and then oh, mm, oh yeah, then I think even here let's just let's see. Hmm. Because we should get some ideally some length here. Also, keyframe inflate should definitely higher than the one below. So extracting size should be greater than extracted size. Okay, it is, which is good. It is the correct size as well, which is even better. So something is happening that's wrong here. Hmm. Okay. See, uh, decoded frames equals append decoded frames frame. This looks fine. Let's now print here. Uh, data size %d encoded frames. Decoded data should be, yeah. Now let's also do the frames data, right? Frames data here. Uh, deflate. Oh, yeah, that's wrong, man. So I'll enter decoded data size frames. Yeah, coded data size 110. Okay. So there's something wrong that's happening here itself in the decoded frames. Yeah. Okay. Hmm. What is the issue? Maybe since we are appending, I can put this as 0. Although I don't know what effect or how does that affect anything. I guess it's appending in the wrong memory location. That could be it. Yeah, that could be it. Who knows? Let's see. Oh, compression takes a long time, no? Okay, yeah. So that's the case. It was basically this was supposed to be 0. So kids, whenever you append data, make sure. Yes, it is, yeah. Okay, so we must have a decoded dot. Let's play that. Let's play that, guys. FF play. So we'll play decoded.yuv video. Decoded. Oh, hell yeah. Flawless. I like it. Dude, what? This is crazy. It's almost like it's working. Let's go. Hmm. Nice. These are all utils. You know what? In the interest of utils.go. Actually, not yet. Because then the compiling this thing list becomes long. Yeah, we'll do it in the final polishing up where I can just separate out all the functions into different files. Right now, what I want to do is uh, convert or decode this entire thing into RGB24. Yeah. So return decoded frames. Okay. Why is it unused parameter? Right. Yeah. We will now stop using this, and because I think there was never an issue in bytes template. Like, yeah, like that part was happening flawlessly. At least that's what I think. Let's see. We'll get to know. So we have this thing decoded frames correctly. So now what we want to do is function. Yeah, nice. YUV convert YUV to RGB. No, that's what. Let's see. How did it go? So read frames done. Converted frames. Yeah, so converted frames we get, and then yeah, I think the next step is just that uh, convert YUV to RGB. So for this, we'll require width, height, obviously. So everything is the same as the previous function, right? What is that function? Let's convert. Yeah, this is the one. So we'll just copy this signature, we'll go here, paste it here, and we'll just swap out the names. Okay, RGB, convert RGB to RGB. Wow. Oh, also, yeah, this was a neat trick. I found out that we can just do this to replace stuff. So if I just do Control R, oops, not Control R, capital R, Y, V, convert YUV to RGB. This is RGB. Yeah. Okay. Convert YUV to RGB. Yeah, that's right. Width height frames. No, we call them decoded frames. Yes, so decoded frames, and then we get the normal, or we will return the normal frames, right? So for I, comma, frame in decoded frames, in decoded frames, okay. Yeah, this is just going to be straightforward. Let's just do Y. Let's just go up and see what Y was. Me all of this. We don't need to do that now because we already have the compressed values of Y, right? What we want is this. Yeah. So what did we do was width times height. Uh, okay. Okay. I understand it now. I understand it now. How did we do it? Is this, right? We took 4 of Y and we compressed, we basically took normal Y and we compressed, or we didn't compress any Y, sorry, my bad. We took 4 of U and V and we compressed them into 1 and 1. So what we want here is, since our ratio here, uh, subsampling ratio was 4 is to 1 is to 1. This means super sampling ratio similar. Or actually, this is okay. Subsampling ratio was 4 is to 1 is to 1. Okay, that's all. Yeah. So for this, it will be decoded frames of from the start to height times width. Then U is going to be decoded frames height times width by 4. Uh, oh yeah, but that will make it shorter. So yeah, it's height times width. Yeah, this is correct. B, this will be height times width. Okay, so uh, um, it's supposed to be 3 by 4, no? Like, oh, actually, yeah. Just why even bother with all of this? Just go all the way to the end. Yeah, that's too bad. Right, so we get YUV now. Original frames equals original frame is made made by by uh, size of what? Height times width times 3. Height times 3. Because we want all the channels. Yep. For J, height. Okay, what do we do now? Original frame. So So it's 64. We'll do y of j. K by 2 and j by 2 also. Also width by 2 as well. J by 2 width 2 k by 2, yeah. This is right. Okay. Because then that becomes 4, no? Yeah, float 64. Mm, okay. Okay, nice. We have all of this. Now we can calculate the RGB values. Oh, yeah, one more thing. We need to subtract 128 here. Again, this is the same reason for why we added it there while converting it. It's because uh, we are just taking it from uint to this float value, and after actually converting it to float 64, we want to restore the original behavior by reversing that offset. So I'm just doing it now ahead of time instead of doing it, yeah, again over there. So our let's look at, we have the formula for RGB, inverting transform, yeah. So R equals Y plus V times 1 minus R upon W max. Sorry, V max. V plus V1 minus WR by V max. G equals Y. Okay, I hate this. This, if it has subtraction all along, then that's bad. Yeah. V minus U. No. And then U. Yeah. Yeah. So it's the small one. It's U WP1 minus WP times U max by WG. Hmm. 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 Minus VWR. VWR. No, 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 no. No. Minus. Hmm. Uh, by WG. This could actually be so much easier if I just did some math. But I refuse. I refuse to do maths. Yeah, this is multiplication, so it will happen before subtraction. That's fine. Yeah. Okay, cool. Um, U1 minus WP by U max times U times 1 minus WP by U max, and that's added by Y. Okay. Yeah, I think this is pretty straightforward. Yeah. Nice. Cool. Um, yeah. Yeah. Okay, great. Hmm. RGB. This is B. Uh, okay. So we did the conversion. Yes, original frame, and then we will do into 8 R G B. Okay, also, yeah, since we are doing this, we need a clamp. So let's just define one like word value, any value. So val int Okay. If income max, both of them are float 64 is less than min, bottom min greater than user. Oh wait, what? Plan R 0, 255, no? Isn't that like the value for our GP? Min and max value 0 to 255. Yeah, I knew that. I was just confirming. Mm-hmm. Hmm. So decoded is user. Now original frame is under decoded. Also decoded frames cannot have actually, yeah, append. I just realized it has to be the I equals original frame. Okay, great. You can return frames. Right. And whoa, what? What? Oh yeah, my bad. It is range for frame, original frame. Oh, he said frame, 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 right in here. Mhm. Why not? Uh, okay, but then there we go. Ah, hmm. RGB. Okay. Encoded frames. Okay. So we have the decoded frames now. RGB. No, we call it reconverted frames. Where and coded frames. RGB. Mhm. Let's see. Extracting decoded. Okay, nice. Okay. Yeah. Oh yeah, sorry. There is no huh. Yeah. Well, there was a command ffplay-f draw video pixel format 4 size 624 by 832. 624 by 832. And I don't know the frame rate. It's 60 and it's original. So I mean on the iPhone I took it at 60 FPS. Maybe it's not. No, 210 30. It's glorious. I love it. Nice. I mean, we've pretty much accomplished what we wanted to do with the codec. Mm, okay, let's remove this. Oh yeah, we need to show the size of frames as well, no? Uh, let's do that. Let's remove this. Oh, was it 4:2:0? Okay, I thought it was 4:1 because we're keeping both this thing. Yeah, sampling ratio niche होगा. Oh, the jitters. Yeah, size. Mm, so, okay. No, we want log not info. No, default. Mm, what the heck? Is it? It's frames only, no? Oh, that's fine. No, because I think keyframe deflates would be an issue after. Yeah. Hmm. No, sorry. Yeah. Official term is deflated data, and its size is percent d. And what's the size going to be? It's going to be keyframe dot length. Oh, hmm. Okay. Um, log dot print element. Actually, never mind. It does not matter. Yeah, port video. Let's go. Oh, what? Oh, that's the. Yeah, we'll remove that because that's like redundant. Okay, so decoded data is here. Let's play original to RGB. We get the entire this thing. Like now, we will also play this thing. What do you say? The what? What is happening? 325 by so yeah, this is great. So I mean, that's the only thing that we want to work. No, I'm not sure. Decoded. Uh, decoded YUV. Decoded frames. So Why was it so bad, dude? What? Yeah. Was this size wrong? Why is the compression so noisy? Oh, I have no idea. So I can like basically make out some landmarks from there, but not all. Yeah. So what I think is happened is let's check. Could be because of encoded frames. Yeah, we got all of this. Oh, I think I know the issue. Where are we adding? Oh, so let's clamp these as well now. I guess it's not required, but uh, I'm not sure why are we. Am I entering the wrong command? That could be it. Because decoded was working fine before now. 6248. Because, yeah, no, a few moments ago, port video, original. Okay, let's. Right, let's see what it shows. Because I'm finding it hard to believe that. Uh, let's commit read added decoder logic. mm, Okay, that's a big fact, apparently. Yeah, let's just commit this. Commit custom. Let's push this one. Anyways, we can run a command and yeah, extract this. So that's not a big deal. Encoded video is fine. It's perfect. Yeah. Why is the decoded video so bad? So okay, we can see the little lines. You know what it looks like? It feels like uh, we have like some overflow that's causing this issue. Because ideally this should not be the case. Yeah. Oh, maybe let me try doing that. The earlier fix. Uh, what was it? Deflated bytes. Yeah, I will take. Printed bytes. Okay. I'm not sure if that is the issue. Let's see. Who knows? If that's the issue, then there is something wrong with our decoding or the way we are extracting the stuff from the file, right? That is concerning. No, okay, no. I think I'll have to investigate that. I'll check it once offline as well once I get time. I think right now this is all I have time for now. Yeah, I was just going to replace this change that was made. Mm, yeah, I think that's it for this stream. Thanks for watching if you have watched so far, and I'll see you tomorrow. I think I will be doing one tomorrow because I want to fix this decoded issue. I will, I think, fix the issues surrounding this as well. Not issues, but we'll basically split up all the code into nice files. We'll create like a proper final script, a README file, basically polish this project up completely. I think that's it for this live stream. Bye.